All right, today we are going to move into activity 25 with two more of our parent graphs. So the parent graphs that we're looking at today are the square root and the cube root. So the parent graph equation for square root is just y equals square root of x. For cube root, y equals cube root of x, or f of x equals square root of x, f of x equals cube root of x. Remember, the parent functions are the most simple version of that type of equation. So we've got no other numbers going on, anything added, subtracted, multiplied, all of that good stuff. So if we want to see what any type of function looks like, and remember, this is a strategy for you. If you forget what a parent graph looks like, just make a t-chart. We can always pick values and plug them in. If I plug in -2 for x, I get square root of -2, which would be I radical 2, which obviously is an imaginary number, so I can't graph that. Same thing with -1. If I plug that in, square root of -1 is I, and that doesn't create anything on a graph either. When I go to square root of 0, though, I get 0. So 0, 0 is a point on my square root parent graph. When I plug in 1, square root of 1, also 1. So this guy right here. So it kind of looks like it might be making a line until we get to this next one. Square root of 2 doesn't come out nicely, but if we put that into our calculator, square root 2, we can see that the approximation is about 1.41. So 1.41 would be maybe about right here. Now, when we do parent graphs, generally try not to use decimals. We try to use nice, easy things to plot. So if I do square root of 3, that's not going to come out nicely either. But square root of 4 does. If I put 4 in here, square root of 4 gives me 2, and so I'd have the 0.42. So 1, 2, 3, 4, 2. So here's what my square root graph looks like. I call these the eyebrow graphs because that's kind of the shape that they take. But we always want to have a parent pattern, and the parent pattern always comes from the t-chart, choosing the 3 easiest, most convenient points. So the parent pattern here, the 3 most convenient points that we're going to use are the ones that come out nicely, no decimals. So our parent pattern is going to be 0, 0, 1, 1, 4, 2 on that square root. Now I'm going to go on over here to the cube root graph. So remember that cube roots, I'm allowed to have negatives underneath. That doesn't hurt anything on these. But the cube root of -2 certainly is not like a nice round number. So cube root button is in your math menu. It's right here, choice 4. So if I do cube root of -2, that gives me -1.26 approximately. Cube root of -1 does come out nicely because the cube root of -1 is -1. Remember that when we're taking a cube root, and again, we had our calculator to check here, but what we're asking for is what, when I multiply it by itself 3 times, gives me that number. So when I multiply -1 times -1 times -1, it does give me -1. Now, next one is cube root of 0. So what, when I multiply it by itself 3 times, gives me 0, would still be 0. So I've got -1, -1. I've got 0, 0. And then 1, cube root of 1, also 1. Cube root of 2 is going to be the same as the cube root of -2, except it's going to be a positive value here. So 1, 1 would go here. Then I've got 2, 1.26, so about right here. And then -2, -1.26 would go about here. Now, from these ones, it's somewhat difficult to understand what the parent pattern is doing. So I'm going to extend it again to get more values that come out nicely. So when we did our factoring of sum and difference of cubes, we listed out the perfect cubes. So 1 cubed was 1. 2 cubed is 8, which means that the next values here that would come out nicely are 8, and then on this side, -8, because the cube root of 8 is 2. The cube root of -8 is -2. Now, obviously, I can't fit that on here if I'm counting by ones, but that is what we're going to use in our parent pattern if they fit. And the reason why I want to put them on here is because I want to make sure you see the shape. When you draw a cube root graph, you should never try to draw it all at once. It should always be in 2 steps. You draw what looks like a square root graph, so that eyebrow shape, because we wouldn't get up, we wouldn't touch 2 until we got to 8 all the way over here. So it's a very slow incline there. The bottom is just like the upside down version. So be weird eyebrows if they're upside down, but kind of that same shape. If you try to connect it all at once, people never get it looking right. So try very hard to just do that in 2 steps. Eyebrow graph, upside down eyebrow graph. Our parent pattern then is going to be -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Sometimes the -8, -2, and 8, 2 won't fit. Now, we can make them fit by counting by 2s or 3s or whatever we need to sometimes. But if the graph is already scaled and it won't fit, then we won't use it. So when we look at these graphs, my domain, my x's, the first, as I'm running my finger along the x-axis, the first value I see is 0, and it's included. So that means my domain starts with a bracket, starts at 0, and then I've got an arrow on this end, so it's going on forever, so that'd be infinity. Range, as I'm going down to up, first value I see is 0, and also the arrow slowly, but it is continuing to go up, so we'd say to infinity. If we were using an equality format, this would be x greater than or equal to 0 and y greater than or equal to 0. On the cube root, we've got arrows on both ends, left, right, which also down, up. So domain and range on cube root is always -infinity to infinity. So these should be gimmies when we ask questions on the homework or on an assessment. Domain and range and cube roots, always -infinity to infinity, no matter what transformations we have. These guys will change based on the transformations, but these will not. All right, so now we're going to talk about our transformations. Remember that our values do the same thing that they've done since the beginning of the year. When we learned those absolute value graphs, the quadratic graphs, it's the same exact transformations. Notice that we don't have a b value in here. You will not be given any problems that have a horizontal shrink or stretch. Doesn't mean it doesn't exist, it's just that we're not using it in the scope of this course. A, remember, and this goes for the cube root as well, controls 2 things. It controls vertical shrink and stretch. So this is a vertical stretch if the absolute value of A is bigger than 1. Also gives a vertical shrink if the absolute value of A is between 0 and 1. And again, none of these are any different than before. The other thing that A controls is if it's negative, which is why we put absolute value over here, because the negative doesn't affect whether it's a shrink or a stretch at all. What the negative would do means that there would be a reflection in the x-axis. H, just like it always does, controls horizontal shift. And just like always, if it's a plus H, it goes to the left. If it's a minus H, it goes to the right. And then finally, K, just like it always does, controls our vertical shift. And if it's positive, it goes up. If it's negative, it goes down. So it doesn't matter whether it's a cube or a square root graph, the transformations are going to be the same. It's just we're going to use a different parent pattern. So let's get into looking at some examples. It is good to point out, remember that, and maybe we should write it up here. Let's go ahead and scroll up here. Remember that this is the same, square root of x is the same as x raised to the 1/2. Those mean the exact same thing. Cube root of x is the same as x to the 1/3 power. So really important that you're able to recognize those, because you will have those in homework and or assessments. If you prefer to rewrite it, you can do that. You don't have to, but this means the same thing as 2 square root x minus 3. So if it's easier for you to work with it when it looks like this, you can feel free to change it. But x to the 1/2 means square root of x. So when we're looking at this, I've got a number multiplied in front, which means it's an A. A is 2, so not negative, bigger than 1. So that means we have a vertical stretch by a factor of 2. Then this minus 3, that's on the end, so that's a K value. So that is a vertical shift down 3. Now, just like all the recent parent transformations we've done, my suggestion to you is that you do the shifts first and then write out your parent pattern. So if I do my shift, in this case, it's just down 3, down 1, 2, 3, and I mark that point. You want to mark it with your little plus sign like we did with the trig graphs. Then I'm going to do my parent pattern. So my parent pattern for a square root is my 0, 0, 1, 1, 4, 2. And what I do with the parent pattern, remember there aren't going to be b values. It's just a, which means that a value, whatever it is, you multiply by the vertical column. So in this case, a was 2. So times 2 on my vertical movement. So this stays 0, this becomes 2, and this becomes 4, which means from my plus sign, I'm going to go left and right 0, up and down 0. So that means it stays right here. I've got a point right there. Then from this point, I'm going to go right 1, up 2. So right 1, up 2, make my dot. Then right 4, up 4. So 1, 2, 3, 4, 1, 2, 3, 4. And remember that the shape is like an eyebrow. Sorry, doesn't look super good here. It's hard to connect with this drawing tool. And we've got an arrow going there. My domain, my x's, first x value as I trace along the x-axis is still at 0. And it's going on forever in the positive direction, so 0 to infinity. My y's, however, have changed as I go down to up, the first y value is now at -3 and goes up to infinity. All right, let's do another. This one is a cube root graph. So list the transformations. My A is -1, so that means that there's a reflection in the x-axis. Remember that 1 does not cause a shrink or stretch. So I'm going to have the same width as the parent. It's just going to be reflected. Then I've got this +2, which is underneath this time. So that's an H value. So that's a horizontal shift left 2. Now, you need to make sure you pay attention to which parent we have. This is a cube root, so this is going to have the double branches. And when I look at my parent pattern, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2 is the pattern that I'm going to use this time. My shifts, I'm just going left 2. So left 2 would be right here. That's going to be the start point from which I'm going to do these points. Now, reflection in the x-axis, my A is -1, which means all of these get multiplied by -1. So that gives me -8, 2, -1, 1, 0, 0, 1, -1, and 8, -2. So it switched all my signs. Now, from here, I'm not going to be able to fit unless I change my scale, which I could change my scale pretty easily, but I probably want to switch colors. If I want to count by 2s on my x-axis, that would allow me to fit more in here. So I'm just going to mark it that way so I count by 2s. Now, if I do that, that means that my shift is no longer the pink. It'd be right here in the blue. And from that blue, I would go left 8, up 2. So 2, 4, 6, 8. And then I'm still counting by 1s on the y-axis, up 2. Then left 1, up 1. So that'd be half a space here, here. 0, 0 means that point itself. Then right 1, down 1. Then right 8, 2, 4, 6, 8, down 2. So when I connect them with 2 separate steps. So there's 1, and here is the other. Remember that domain and range on cube roots is always -infinity to infinity, regardless of the transformation. So that should always be an easy one. All right. This one, I've got a square root this time. So in front, I've got an A. It's 1/2. So 1/2 is between 0 and 1. So this is a vertical shrink by a factor of 1/2. Then this is an H value. It's positive, so it goes right. So horizontal shift, right 1. This guy's outside, so that's a vertical shift. Since it's positive, it's going up 2. So right 1, up 2. This is going to be my start point right here. My parent pattern, because it's the square root, is just these 0, 0, 1, 1, 4, 2. I'm going to be multiplying by the A, which is 1/2, so times 1/2 on all of these, which this guy stays 0. This becomes 1/2, and 2 times 1/2 is 1. So from this point, I go right and left none, up none, because in this case, where the plus sign would be is always actually going to be a dot. So you can go ahead and just make them dots if you want. Write 1 up a half. So that'd be right here. And then write 4 up 1. 1, 2, 3, 4, up 1. There's our graph. We can look at it. Trace your finger along the x-axis. The first time I get an x value is right here. So that means my domain starts at 1 and goes to infinity. It's going on forever. If I trace down to up on my y's, down, down, up, up, first y I get is at 2 to infinity. Notice that my domain connects with my horizontal shift, my range connects with my vertical shift, and that's always going to be the case. All right, last one. These ones are a working backward when you've got the equation and you're asked to find the value. Now, I can see that this guy is kind of my center point. That's going to give me my h and my k, and that point is right now at 2, 2. So that means I've got a horizontal shift right 2 and a vertical shift up 2. I also know from the shape that this is a cube root, not a square root. So now I just need to figure out what the a value is. The branches are going the same way as the parent, so I know it's not negative. I know that normally in my parent pattern, once I've got my 0, 0, that it's normally -1, -1, and 1, 1 would be the next 2 points that are marked. In this case, I have 1, 3. So what was a 1 is now a 3. Same thing here. This would be -1, but now it's -3. The way that that happens is that we multiplied by 3. So that means that that's my A. So I know my H, I know my K, I know my A, so I can write my equations. So f of x or y equals 3 cube root x minus 2, because I went right 2, plus 2 on the outside because of that vertical shift. You could also write it doesn't have to be f of x, you could use y also, but we could also use that 1/3 power instead if we wanted. All right, we've got lots of examples, and like I said earlier, these are all the same transformations that I think most of you are really good at by now. So make sure that you stop by office hours or let your teacher know if you have questions.